With a nod to Bob Shaw in Phoenix, Arizona, I've titled this video clip, "Are Humans Smarter Than Yeast?" This video clip is about exponential growth. 2% per year, 3% per year, 7% per year. Any X percent per unit time over time characterizes exponential growth. Steady exponential growth will exhibit a constant doubling time, and this is important. Consider a doubling time of 1 minute, say of bacteria in a growing medium. Assume 8 units of bacteria after minute 1. It grows to 16 at minute 2, 32 units at minute 3, growing exponentially 64 at minute 4, 128 at minute 5, 256 at minute 6, 512, 1024, 2048, 4096 at minute 10, more than 8000 at minute 11, more than 16,000 at minute 12, and so forth. Each doubling equals the quantity of all the preceding doublings combined. You can calculate the doubling time simply by dividing the percentage growth rate, 2%, 4%, 7%, or X percent, into 70. 70 divided by 2% per year, for example, gives a 35-year doubling time. 70 divided by 7% per year gives a 10-year doubling time. 70 divided by 10% per year gives a 7-year doubling time. As the exponential process matures, the quantity of each next doubling becomes extremely large very quickly. For this thought exercise, we went from 8 to more than 2 billion in a mere 28 doublings. At some point, the bacteria in the growing medium suddenly eat or pollute themselves to death. It's called in biology overshoot and collapse. Now consider a $1 bill with a thickness of 1/10 of a millimeter. How many doublings of 1/10 of a millimeter would reach 239,227 miles, the average distance from the Earth to the Moon? A stack of dollar bills. A, more than 1,000 doublings. B, 500 to 1,000 doublings. C, 100 to 500 doublings. D, 50 to 100 doublings. Or E, less than 50 doublings. A stack of dollar bills from the Earth to the Moon. "42 doublings of the 1/10 of a millimeter thickness of a $1 bill would reach well beyond the average distance from the Earth to the Moon." That seems like not very many. After spooling up, doublings rapidly generate enormous numbers. The growth in any doubling equals the total of all the preceding growth. Now let's say you and your neighbors live near the edge of a lake. Somebody introduces a rare species of lily pad that grows with a doubling time of 1 day. For this thought experiment, the lake is of such a size that it becomes completely covered on the 30th day, which for you and your neighbors is a serious problem. Realistically, at what percent coverage do you and your neighbors notice that you have a problem, a growing problem? A, when you see the lake is more than 50% covered in lily pads. B, 25 to 50% covered. C, 12 to 25% covered. Or D, when you see the lake is 6 to 12% covered in lily pads. Given exponential growth dynamic, your time remaining to respond, if you noticed you had a problem when you saw the lake was more than 50% covered, would be the last day. If you noticed a problem at 25 to 50% covered, you would have 2 days. If you noticed a problem at 12 to 25% covered, you would have less than 3 days. And if you noticed a problem early, say 6 to 12% covered, you still would have no more than 4 days. It takes 26 days, growing exponentially, before the lake is a mere 6% covered. Most of us would not recognize a problem until the lake was more than 50% covered. That would give us, as I said, less than 1 day to respond. Now imagine the magic of technology allowed you instantly to double the size of your lake. How many more days would that get you? Only 1 more day, the 31st day. Technology is hardly a solution to exponential growth. Now, also consider that human response involves inevitable delays. We delay trying to agree about a problem. We delay trying to agree about a solution, even when we agree about a problem. And we delay trying to implement a potential solution. Every doubling in consumption, waste, pollution, and destruction becomes an experiment. Experiment about limits to carrying capacity, and limits in human ability together to recognize what's happening and to respond constructively. There are natural limits to continued exponential growth. They include shortage of arable land, clean water, oil and natural gas depletion, global warming, pollution, resource conflicts, war, and economic instability. Indiscriminate exponential growth makes every growth problem worse. And almost every politician, economist, and businessman implicitly extols indiscriminate exponential growth. That is 2%, 3%, 7%, or some X%. Exponential growth in consumption, pollution, and/or environmental destruction. So I ask, will humans recognize the dangers of rapid change, late response, and delay? Will we continue to accelerate exponentially off the cliff to disaster? Are humans smarter than yeasts? Thank you for watching this video clip. You're welcome to join us in learning-oriented conversation at learning-communities.net.